Physics Varied Assessment 2007. Kayaking, the physics behind it. Kayaking is a sport empowered by Newton's laws of motion. A kayaker pulling the paddle exerts a force on the water. Due to Newton's third law of motion, the water exerts an equal but opposite force on him, causing him to accelerate. According to F equals to ma, the acceleration is dependent on the mass of the kayak and the person, and the force the kayaker exerts using his paddle on the water. However, there's much more going on when the kayaker propels himself forward. This includes torque, this being the reason why the kayak swings in the opposite direction of each stroke. Moments is involved in kayaking too. Notice how the left hand is used as a pivot, while the right hand exerts a force to create a torque. A wide blade with a larger surface face can provide greater acceleration due to greater resistance in the water. A long narrow blade, however, will take more strokes to move through the same amount of water. The weight of the paddler is supported by an equal and opposite force from the upthrust of the water, bringing about stability. When the displacement of the kayak moves the center of gravity past the center of buoyancy, it causes the kayak to be unstable, which may then capsize. Notice the boat is tilted, but not to an extent where the kayak will capsize. Now, for an example of an unstable kayak. Similar to an object traveling in air, the greater the velocity of the kayak, the greater the resistance. Look at how speed increases with the drag force. A rudder could be installed to help turn the kayak. However, other means also could be used. This includes paddling on one side. Paddling on one side will cause the kayak to change its direction. Thank you for your attention.